Hey friends, so this will be the last video for Unit 3, and it's on proving triangles isosceles. We've worked a little bit with isosceles triangles in other proofs, but the goal of these proofs is to prove that a triangle is isosceles. What this generally involves is proving two other triangles congruent, and then using the corresponding sides or angles to say, if these two angles are congruent, then the whole triangle is isosceles, or if these two sides are congruent, then the whole triangle is isosceles. So, the first part of this proof that we have here, it's, friends, it is so easy. They give you three givens to prove these two triangles congruent, and if we're looking at this, pause the video if you want to, take a moment to look at this. They give us that ADE is congruent to BDF, DE is congruent to DF, and AED is congruent to BFD. Just from those givens, we get angle side angle. So all three of our first givens, they're just freebies. They just are freebies so that we can prove these triangles congruent. So I'm going to pause the video, type that all in, and we'll start from there. Alrighty. So as you can see here, I've done my three givens. They were all freebies. I proved my triangle is congruent using angle side angle. So now, if we remember back, an isosceles triangle is a triangle that has either two congruent base angles or two congruent sides. If we're looking at this, we can't really get these sides congruent because they aren't a part of the whole triangle. And we can't use segment addition because they aren't sharing a piece. But if we are looking at this, both of these triangles have this angle. And if we can prove this angle congruent, then we can prove the whole triangle congruent. So our step 5 is going to be the corresponding parts of congruent triangles. Our theorem is that congruent triangles have congruent corresponding sides and angles. So our conclusion is that angle A is congruent to angle B. There we go. Since these triangles are congruent, all their corresponding sides and angles are congruent. So we can say that this angle is now congruent to this angle, and since that's the case, we can now say that this is an isosceles triangle. So, going along with this, our next line will be a theorem saying an isosceles triangle has two congruent base angles. I'm just using that from my head. That is the definition of an isosceles triangle. You can kind of re-engineer the isosceles triangle theorem that's on the definitions sheet to say that, but we're pretty much there. And you don't need to say that it has two congruent sides as well, just because we just want to prove that's an isosceles. So our conclusion here is that triangle ACB is isosceles. Done. Okay, so proving a triangle isosceles, you're trying to either get two base angles congruent or two sides congruent. So now you can either go on to question 6 here or do it in the Desmos, whichever you prefer. Although the Desmos is what's due, so I'd recommend doing that. Okay, bye!